Yo, 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 what up? All right, today we're going to be unboxing the USB-C flashlight. Kind of cringe because I actually, there are no keyboard coding. I mean, maybe, maybe, maybe later today, keyboard coding. I'm like, it's a tricky balance. I want to be able to focus completely on a project, but at the same time, I need to have enough incoming unboxings. So I'm trying to get to one electronic board a day, but we will be doing the keyboard coding at some point. So Fern, I don't know what Sofern is. I saw that your solution was to download the PCB from JLC. Yeah, so basically I just got the pad numbers wrong. When I ordered them from JLC, the pad numbers were different. I just changed them to fix the auto router. So like actually a big effort today is gonna be we're gonna do a bunch of stuff with the auto router like today and tomorrow. So yeah, I'm not sure when the keyboard coding will happen. But soonish. The thing is like I know it's gonna work. Like, and so it's slightly less interesting to me because the challenge level, once you get into software, the challenge level goes down so much. But I'll finish up the keyboard at some point. Let's jump over to the lab desk. Uh, so we've got the keyboard still. I have nowhere to put my stuff. I'm working on that. So you can create scene buttons with that. Scene buttons? Oh yeah, like with the cameras for sure. It's definitely scene buttons. But anyway, your own Elgato. Oh, I see what you're saying. I could do that. That's a really good idea. Yeah, to have scene buttons, like I press this and it does like an OBS thing. That's a great idea. um, but anywho, let's jump over to unboxing this LED flashlight. This is gonna be a quick one. I don't expect this to be too crazy. The only thing is, this should have been impossible to assemble. I sent 2 boards with our USB-C connector, which was wrong, and they sent one back, and then this one they did. So I am very curious how they assembled this impossible board. Maybe they figured out a way to shove the USB connector in our incorrectly sized hole. Okay. So this is more accurate than flat. This is our first board with a USB-C connector. So it's really just making sure we can get a USB connector. Like yeah. All right, let's see. So I'm going to open this guy up. Wow, these are tiny. I didn't expect them to be that small. Look how cute these are. Let's get the other camera open. I was thinking about adjusting this camera too. Like almost like up here and then make this guy. I don't know if this is going to work. Oh, I don't know about this. All right, I'm going. You know what? I'll try it. I don't know about this configuration, but at least my head is on top of one of them. Okay, so yeah, they're really tiny. Let's do that. Okay, they're really tiny. I didn't realize they would be that tiny. Yeah, they shoved it in somehow. Yeah, that's crazy. They shoved it in. I'm blown away, but anyway, look how cute this thing is. Yeah, USB-C flashlight. Yeah, so basically just a button with a USB-C connector and an LED, and this is mainly just to test our ability to do USB-C connectors. It sounds dumb to test these little things, but like that's not something you want to order a really complicated board and then be like, "Oh, I didn't do USB-C right." They did. It's gonna be hard to show, but they did shove those connectors in. I don't think we can see it without a microscope. I do have a webcam microscope that just arrived. I haven't set it up. I've been working with a company that sent me 4 microscopes at this point, and they keep saying the firmware is going to be fixed, or three microscopes at this point, and yeah, it just doesn't work on Mac. So this is most likely to explode of anything we've ordered so far because we've never done the power stuff ourselves. So let's blow it up. Better question is, will it work? Yes. Another thing I noticed after I ordered this is I did put the wrong ohmage resistor on. I put a 1K because I'm like dumb and use 1K as a placeholder all the time. So it might be really dim. It might be extremely boring. Maybe I should have done the stream at night, but so that it would come through. But I need to clear off this desk a little bit. Oh my gosh. Let's clear this off slightly. Okay, USB-C connector. I'm going to go ahead and put in like the chunkiest, most powerful connector I have. This can certainly deliver a lot of power. But how USB-C works is your board, this PCB, actually negotiates the amount of power delivery. And if it doesn't negotiate, then the guy on the other end, if it's made correctly, will negotiate for or will give it like a very low amount of power, USB 2 power by default. So yeah, let's plug this guy in. Plugs in okay. And then, so theoretically it's powered, nothing's hot. And then we press this button and hopefully the LED, oh, uh-oh. So maybe this was, either this is wired backwards or, well, that's not good news. Oh boy, that's kind of sad. It's such a simple board. Well, that's why you test these things. I don't see that LED going on. I do not see any spark of LED going on. Very sad for our tiny little USB-C test board. Let's try the other one. Yeah, continuity test. That's a good point. Yeah, maybe the next best thing to do is a continuity test. Yeah, let's do it. Let's do it. That's not a bad idea. I have a theory. Maybe I messed up the diode too. So let's jump to the design really quickly. Like I said, I make these designs so fast because the goal is to get to one circuit a day. So I'm like going through as fast as possible. And if I make a mistake, I'm gonna, instead of like being more careful, I'm gonna fix the software to catch my mistakes. And a misplaced diode is definitely somewhere where you could do it. So we're going to snippets.tscircuit.com, and then we're going to search for flashlight, I think. Yeah, USB-C flashlight. And we should get our board. Oh, so there could be a couple things here. Oh, I just ordered another button board, so I really hope this isn't it. But I asked ChatGPT, and it said as long as you connect the diagonals of a push button, they'll always be connected when you press the button. So I really hope that that's true because I just ordered another board that followed that pattern. If not, I can fix that by like doing a small wire on the bottom across here. So now that I have a lab. But anyway, how this works is you have your power here. Let me maybe move this over here. Oh, nope. There's nowhere to move it where it's in view. Let's go over here. That's probably the best place. So how this board works is we've got our V-bus power here, which we'll have to check. It goes to this push button. These are supposed to be connected when it's pressed. These go to a 1K resistor. And then you have your positive here, your negative here. So I think that diode has got to be on right. And then that goes back down to ground. We do not have any power negotiation circuitry on this. So how you negotiate power is you put some, I think 50 ohm resistors across two of these, across the, I think it's SBU maybe. Let me see if any of these ring a bell. CC, that's configuration something. So configuration control, maybe, I don't know. But anyway, yeah, let's see what's going on. Let's try to check the power. This is gonna be tough. I might actually, maybe I'll do two unboxings. I might take out the other microscope because it's just gonna be really hard to show what I'm connecting without that webcam because this other camera doesn't really zoom. So let me do a second unboxing for this microscope, and then we'll try to plug it in as a webcam. I knew junk like this was going to happen. That's why I order little baby circuits, because I'm like, you know what? Test as you go. It would also suck if Snippets had a bunch of circuits that had never been tested. Oh, this is kind of funny. I got to send this to my girlfriend. The way this is packaged, we were trying to figure out how to repackage it. And we couldn't figure it out. We were like, everything surely must go in the inside of the box. And it turns out it does not. Some stuff is kind of outside the plastic container and just kind of sitting in the cardboard. So, all right, new microscope. Let's do it. Measure the voltage too. What does it pull / receive? Absolutely. 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 Yeah, I think the plan is to make sure that the USB-C is giving power as well. So we're going to measure everything. You name it, we measure it. How do I assemble this? I'm just kind of guessing. I've already assembled 2 of these, so. I hope this is right. This could be upside down. It's kind of ambiguous. Wish I can join you. I really love this stuff. Just don't got the time to build and play around. I'm with you. I'm with you. I'm with you. Yeah, I mean, the whole goal is to make this stuff so easy eventually that it doesn't take that much time. Like, you can order things fully assembled. I do think, like, something that I would love for TS Circuit users and myself would be like a really, really nice, like, little debug kit so that, you know, you don't, like, even the multimeter, I don't know if this is possible, but I don't love multimeters. I would love to have TS Circuit have sort of a convention for test points, and then you can use those little hooks, and then you can use something like an analog discovery, but better than an analog discovery. Like, I have a lot of requirements for my perfect debug setup, so I'll probably build it myself because it's such a good dog food project at some point. And there's really good kind of like open source oscilloscopes coming out. So okay, anyway, we have a new microscope, distinguished by its black base. They told me the black base has the firmware. The one you have does not have the firmware. So let's plug this guy in and see if they were correct. Can TS Circuit check if I'm making a mistake, like a part, like putting too much resistance? Not yet. But that's like super built into like that's, I mean, spice is like some, it's like I have to be good at least one thing first, but I really want to do the spice output. So we have different types of outputs. So there's schematic, PCB, 3D. Spice is another one, and then it will run checks for spice analysis. So long answer, we should have that soon. Wow, how many cameras should I put up here? Should I try? I'm probably gonna mess up my Mac if I put another camera down, but I'm gonna do it anyway. So we're gonna add our microscope, which theoretically should work now. Oh, wow, this one does work. Oh, perfect. Yeah, I think that's working. Let's try to get it something in focus though. There we go. All right. Cool. Okay. So, yeah, I have no idea how to set up OBS to make this like make the most sense for you guys, but I'll try this. We'll see how this goes. So let's bring this scope into focus. Whoops. Oh shoot. Oh my goodness. I like did not tighten everything to an adequate amount. Okay, a little bit of focus adjustment. Hopefully this isn't too zoomed in, because if it's too zoomed in, that might be tricky too. Okay, cool. Yeah. Wow. Awesome. Only took 3 tries, but they finally sent me a microscope that works. So yeah, there's our USB-C connector. And these are the pads that are wrong. Yeah, the pads aren't supposed to be like this. If you look at the pads on the latest design, see how they're kind of like ovally? See that? That's how they're supposed to be. But They're circular here. So they really shoved that thing in. I'm actually very surprised, impressed. I don't know how they did it, but they shoved it in and it felt pretty solid. Yeah, and then we have our resistor, our LED. So very, very simple. Yeah, let's power and probe this. This is gonna be tough logistically for me with so many hands and such a small. Maybe I'm gonna raise this microscope to the maximum height to try to get it to like be as convenient as possible for me. And then we'll do it. This is as small as I can get. So hopefully it doesn't move. I don't have great equipment for this. Use the microscope hands. Yeah, but because there's these things on the bottom, it's like I don't know what to do it to. You know what I could do? Here's what I'll do. We'll use this foam so that it can stay stable, and then I think I can use this. It's a little tough, but oh no, I need to probe the bottom of this. Let me mess around with this for a little bit, and we'll see how difficult it is. The first thing we want to probe is the voltage from, I guess it's kind of hard to touch ground, and the chassis isn't ground. So I'm gonna try to point at these. This is gonna be tough. I should have put test points. I'm gonna make a test point component literally today. This is insane. But so can I point? So this pin right here is ground. And then this one immediately adjacent to it is power. Okay. So that's power ground. So we want to see that those have a voltage difference. Okay. That's where we're starting. I'm gonna put, this is insane. I need a live stream lab. I almost got a live stream lab. I'm telling you, it was very expensive. Otherwise, I would have gotten it. Okay, let's plug this guy in. This is good at the moment. Good enough. Good enough for comedy, I like to say. Okay. All right, I'm gonna really lean in here because this is gonna be tough. So. Okay. Are we not getting any voltage out of that? Yeah, 20. 20 DC. Yeah, I can't do 2 VC. It would go over. USB-C connectors are symmetric. So this side is also ground in VBus, so we can check that. There is the possibility that what I'm using to power this is it requires configuration. That would be out of spec for a USB-C thing, but it's possible. So I can try using like a USB 2 to USB-C cable. Do I have a phone charger? This is essentially a phone charger. It's not from my computer. It might actually be more reliable for my computer. I'm not sure. But let's try it with the other side. I'm like using my laptop as my monitor for the microscope. So you guys are basically seeing the exact same thing I'm seeing. All right. Tough to get in there. Those are tiny pads. Oh, geez. Come on. like holding my breath. You know, do I see a little something or am I crazy? Voltage at first contact? Yeah, there's like, but it's negative too, which my probes aren't backwards today. Another thing we could try, just to see if it's kind of a contact issue, maybe, is I can do this for ground. Wow, I really should have put test points. I have so many regrets. So that one's supposed to be 5 volt 2, this button. So that is also supposed to be 5 volt. Yeah. I suspect this charger is bad. So a couple things we can do. The microscope actually just came with a USB to USB-C. I'm gonna try plugging that into something. I need to find a open. Oh yeah, there's an open USB port over here. No, there isn't. Oh, I can use this. Oh no, there's an open one. I have so much stuff plugged into my computer. I have like 10 USB-C devices. Okay, so you're gonna unplug this cable. Try a different cable. Okay, so new cable. And let's run the same test again. I'm going to use these little clamping microscope arms to keep the USB-C cable stable. I think that'll be helpful. Maybe I can keep this side stable too, like that. Oh, that actually works wonderfully. Okay. Oh yeah, that is clamped down now. That was a great idea. Okay, I'm going to test this side because it's a little easier to reach. Wow, this is tough. I gotta take off my hat. Gotta get close to this thing. Yeah, baby. There we go. All right. Okay, so USB-C cable was bad. Holy moly. You know, electronics are hard partially because of dumb shit like this. I think just like I'm thinking of all the things TS Circuit should do. Every board should have a power indicator, right? Like any like all of our modules should just have that kind of stuff cuz like holy moly, what the f. All right, let's see if this LED goes on with this cable now. So we're going to press this. Yeah, there we go. Okay. So this board worked all along. Bad USB-C cable. Yeah, you can kind of see it on the bottom screen too. So unboxing successful. We know that we can do USB-C cables, and we also know JLC will sometimes, but not always, force your USB-C components into holes they do not fit in. Wow. All right. Cool. It's not that bright, but it's not that dim either. So 1K was actually fine. I think I was supposed to do 330, something like that, but pretty happy with that. Yeah, that's the next thing on my I mean that's it. We got it working. It's beautiful, little it's so tiny. Little flashlight device, easy peasy. Okay. I don't think I would even change anything about that design. I think it's fine for what it is. Like, we'll do fancier stuff. couple things on my docket today. One is to get ESPs working. I really want to get Wi-Fi modules. What I was doing is I was looking at, let's put this guy away. I was looking at like SparkFun modules, stuff like that, and I was like, okay, recreating these is, pretty important. But when we recreate them, they kind of require assembly and testing, and they're really modules. They're like made to be put inside of things. So I was like, okay, how can I do this but actually make it like a standalone circuit? We want to do standalone circuits. So I think what I want to do is take each of these modules and make it a Wi-Fi module. Just like, just make it a Wi-Fi module. Use TS circuit, like drop-in components to do that. ESP32 will be the brains. Yeah. So that's kind of my goal. To get there, most people on the team are pretty suspicious of the auto router working, I would say, for all those use cases, because it even choked on the 9-key keyboard. So I do think that the auto router could get 10 times better with the current architecture, and a lot of that is optimizing so that it has more time available. The free routing guys also released an API, so going to take a look at that. So those are both those are the docket, basically Monday, Tuesday. I have another board coming in, which thankfully, since this USB-C design worked, that'll work. How do you fund TS Circuit Globee? We're VC backed. We haven't announced our fundraising round. It's like in the venture capital world, you don't like, it's kind of like a meme, like you don't announce your round until you're ready for the next round, essentially. So that's why we haven't announced it, but we are venture backed. And actually our first employee, Rashab, started this week. Well, not employee, technically contractor from the US perspective. But anyway, our team is slowly getting started. That's why I can work on this all day and do dorky stuff like live stream all day. So yeah, and then we're gonna, so another like interesting thing is these keyboards that we made. It's so funny how the PCB turns off. I think that's hilarious. But anyway, these keyboards, they currently use the Pico 2, which I love and it's great, but I don't like soldering. So I want to get a version of this that's fully assembled. So I'm going to switch to a board that JLC has in stock. JLC doesn't stock the RP2350. It's too new, but I think they do stock the 2040. Thank you. It is nice. It is nice. Yeah, look, they have 24,000 of these. So I have heard a lot of people don't like these. It doesn't have onboard USB, for example. So there's a lot of downsides to using this, but I just want to commit to like one architecture or one like general chip to use. And Arduino is kind of like the app mega modules aren't that hot. So I really want to commit to just ESP and RP, the RP series, the Raspberry Pi chips. So we're gonna do some RP 2040 boards. I'll probably convert this keyboard to an RP 2040 board, which will unfortunately make it a lot more complicated because this is a relatively underpowered chip, but it's cheap. It's only $1, so it should be fun. Yeah, but for it's probably gonna be like 2 days. I'm just gonna be knee deep in auto router, unfortunately, while we prepare it to be able to route boards like this. Because right now, if I do a board like this, it just won't route. And since we don't have schematics, the routing is pretty important. Although huge contribution today, somebody made it so you can download schematics. I actually have not tried that, so that might be kind of fun. I think that's live. Let's see, download schematic SVG. Oh, yeah, beautiful. Wow. So, I don't know if, schematic auto routing enabled. So let's enable the schematic auto layout and then rerun it. And now we'll download again. And let's see what it looks like. Yeah, so Rishab has done some really good work getting this schematic working, but it's still not that usable yet. Um, I think there's a new version that's way better than this, like 2x or 3x better in appearance. So I will hold out for that. That's going to come really soon. Anyway, basically I'm saying we're doing some spring cleaning. I'm not building boards, too many boards, other than getting the ESP working for the next day or so. Maybe I'll get an RP2040 working, but yeah. So for now, I'm actually off to the lab to get some storage. I have to go in to do some storage and then gonna do auto routing work. So unfortunately off stream, but thank you for joining me for this unboxing. And many more circuits to come. Hopefully we get to one a day. You know, that's the goal. Every day an unboxing, and then I'll also show the design. And when we do ESP design, I'll also do that on stream. Those will be some of the most exciting boards to order because, like, you guys can order them, right? You could you could go to Snippets, you can download the fabrication files, and you can get a humidity sensor or something like that. So it'll be pretty fun. It'll be pretty fun the day we create something useful. My pet circuit that I want to make, like the one I'm most excited about, is a push-up counter, or like a push-up counter or exercise counter that goes on the wall. So I literally just want like almost like a single function circuit, and it just has a camera, and then on device using AI, it computes how many push-ups have been done in that room, and just like keeps a scoreboard. And maybe it keeps a scoreboard for like each of my like each person I register. But it's all, I want it to be all on device, so it's not connected to the internet or anything like that. It's just like a wall mounted push-up counter, something like that. It could also like count different exercises, but like, you know, push-ups are fine. The other thing I haven't talked about too much is I have a ton of e-paper displays. So I want to do a ton of stuff with these e-paper displays. This is a small one, but unfortunately they get really expensive as they get big. But e-paper module. So this could be like the push-up display instead of like your 8-segment display or whatever. I believe this one is black and white. Yeah, I believe this one is black and white, but it comes, it's, you know, it's basically these are sold by the manufacturer. The manufacturer is Waveshare, and these are sold by the manufacturer with a chip that basically does SPI, which is a protocol. And so you don't need much power to run it, right? I would also love to like port some like neural network or whatever to a microcontroller and like just get it to do stuff. I know it's probably insane. Like to store an image is so much memory, right? But I'd love to do something insane like that. So hopefully that's coming up in the near future. But for now, that's the unboxing of our LED flashlight. Thanks for joining, and I will talk to you soon. I will build a new board, maybe one that displays the thing. I have no idea. We will build a board though. All right, thanks guys. See ya.